Hey guys, welcome back to my series where I'm going through all of the challenges in my book, The C Sharp Player's Guide. We are, at this point, we're to, I think, the fourth challenge in the final battle challenge. Um, so the last three challenges are building this foundation that we're going to keep building on here and for the next several challenges. And yeah, so today we're going to be doing this attacks challenge. So far, I can go run this. Well, yeah. So far, we've got two different characters that are each attacking each other. In my name. But they aren't doing any attacks. So far, they've all been choosing to rest. And it's time we add in some actual combat in our little combat engine. So that's what we're going to do here. The, the book describes the details here, that we're going to have different attacks. They've got a different name and other capabilities. That to me seems like that's probably a whole other, yet another class that we want. And then every character has a standard attack, and they're different. We got two characters. We got the true programmer, and we've got a skeleton, and their standard attacks are different from each other. Now, at this point, the only real difference is the name, but there'll be more later. So we need to be able to add in a new action type besides our rest action. We want to be able to add in an attack action as well. And more, just as importantly, like these also have a target. So that's going to require us to put in some extra plumbing to allow us to, you know, be able to specify a target. And then we're also going to update our computer AI that we've got to not rest, but to attack instead. Now, I have seen some people who will still, some percentage of the time, rest instead of always attacking, and maybe we'll incorporate that in here. We'll see. And then also, this allows us, so when the computer is picking targets, we can allow the computer to just either pick randomly or just pick the first one or something like that. So, and now after we get done with this, we'll have this type of thing. The character used the attack name on the target. So, I'm going to scoot that off my screen. I can still see it. You won't be able to because it's on my other screen. But the first thing here is we clearly have this concept of an attack. And I think that means that we need another class. Now, I'm kind of sketching this out in code. We'll write out some, basic like class names and some stuff like that without getting into details. And then after that, we'll flesh it out a little more. So we're going to start kind of basically sketching in code here. The only thing I think this actually needs, we don't need public on an interface. The only thing I think this actually needs is right now is a name for the attack. So if we did like that might be enough to represent an attack. And then we need a punch, which is an attack. And this needs to return punch. And this is a, not skeleton, bone crunch, which is also an attack. All right, so our attacks might look like that for now. There's not a whole lot of meat to them. It's just some really basic attacks. The other thing we need is every character has a standard attack. So we could come down here, this like character, this could have, maybe it's just like the name, abstract, I attack. What did this call it? Basic attack or standard attack? Standard attack. This is the attack that comes just from. This is your melee attack. Your no items standard attack. I think you could make an argument that maybe we could allow characters to have more than one standard attack. The way the challenge is written doesn't demand that, and maybe just to keep things simple, we'll leave it alone. But now we can come in here and we can say this guy's standard attack is going to be that bone crunch attack we just made. And the true programmer's basic attack is going to be punch. So there we've made a basic version. Each of these characters have their own unique standard attack. And now the other thing we need is we had a rest action. What we need here is a second action type, an attack action. And kind of like what we did here, I'm actually going to copy some of this. Like what we did here, we're going to, the thing we discussed when we made this rest action in the first place was this, like, it was a philosophical decision of, let's make it so attacks, like, they have at construction time, they have all the data they need to just do their thing, whatever that is. They're like spring loaded, ready to go. They've got all their data, and all you need is somebody to stumble across it and just invoke perform, and poof, the whole attack happens, or the whole action happens. In this case, it's an attack. In this case, we need like, it needs to be something like used. Well, like something like for the short term here, I'm just going to put used punch on skeleton. But yeah, so we want the character use some attack on the target. So what I think this is going to demand is we need to pass all this stuff in. The character which we already have, the attack, which is new, we didn't have that on the rest action, and a character that's the target. And now we're going to just save all these off to fields. Actually, I think I can just get Visual Studio to generate these for me. Create an assigned field attack. I'm going to do this, but somehow I've got Visual Studio configured, I think, to not use underscores on these. I actually want, like, I want those underscores. So this should be underscore attack instead of, and then I can skip this dot attack. Now that I see this read only, we might as well put that on here. Once these are set up, like, they're primed and ready to go, and they can be read only. So let's make them read only. So we'll do that, and then same here. But again, I don't want it to be no underscore. I want that underscore. So you might have better luck with that. Like I actually think that maybe a long time ago I configured Visual Studio to not do it that way, and I could go mess with the settings. I'm not going to do that right now, though. You might have better luck generating those with the underscore on there. And so now this attack action, as long as when the attack action is, like, prepared, we supply the character that's like the originator, the one doing the attack, the actual attack itself, and then the target. Then this whole thing will be spring loaded, ready to do whatever execution it needs. And in this case, what we want is that. So now we have an attack action in addition to our rest action. We just need the computer AI to use that instead. So we can say return new attack action. And we've got the character, and right now we can just say we're just going to always use the character's standard attack. It's right there, easy to use. This part, though, is trickier. Like, what should the target be? And so somehow we got to figure out how we're supposed to get a hold of the target. something knows what that is. Something like in order like this computer AI, in order for him to make a decision about who to attack, he's got to know like what exists out there. And I think it makes sense in terms of making a, in terms of a player taking a turn. It makes sense for this to have, access to everything that's going on. So if we just pass in another, um, well, so let's just say it this way: if a player has access to the battle, it can make a lot smarter decisions. And again, we go back to the conversation that we've had in several of these videos now about. I'm going to jump back to that in the book as well. This section here in level 23 about how to collaborate. And again, this in the book, this was a very much a rapid dash through object oriented design. It really deserves a whole other book, maybe a whole series of books, but we got a few pages. So this is, like I said, a mad dash through it. And in order for an object to know about another one, we pretty much have to do one of these options here. We could, create a new one. In this case, though, we can't just create a new battle because we need the battle, not any battle. So that one's out. We could pass it in as a constructor parameter. So we could do something like public computer AI player, and we pass in the battle. And then we save this off and have private read only battle. So and then in here now we could do something, battle dot heroes heroes dot characters 0. Like, so now we can get our, if we've got access to the battle, we have access to everything we need in order to get the character that can be the target. Now in this case, we've like even the heroes are gonna attack themselves. This might literally attack itself if it's that first character. So obviously this logic isn't totally right, but we do need access to that battle in order to do stuff. So passing it in here is an okay approach. The catch being, at the point where we're creating these, the battle doesn't exist yet. The battle needs to know about the players, and the player needs to know about the battle. And that makes things a little tricky because we're not going to be able to just pass it in simply. So I think another reasonable approach here is to just say, you know what, player, we're gonna ask you to make a decision here, and we're gonna give you the battle, and that could, like, one thing that does a lot enable, which I think is not like it isn't really a scenario that we super need, but like this could allow us to have one AI player that is playing 5 games all at once if we wanted to. That's something that it could support. Um, so I feel like that's an okay thing to do, to say, look, you're gonna have to make a choice, and I'm gonna give you the whole context of everything that's going on, and ask you to make a decision from that. So I like that notion. That was one of our options. Is we look at this, it was passing it in as method parameter. So we happen to use that one this time. But there were other options, but I think that's the one we're going to go with this time. So once again, this is like, how do we get objects to know about each other? In this case, we had this tricky part where battles need to know about players, so they can say, hey player, what do you want to do? But the player needs to know about the battle. So there's like two-way references. Somehow you got to get them to learn about each other. And in that case, it can't, because they both need to know about each other. You can't create them both like simultaneously and have them know about each other. You have to have an order to it, which means something's got to happen outside of the constructors. So, all right. Let's see. So now in that case, the players will get their context. They'll get the battle. whenever they're told to take a turn. So they know what character they're supposed to be taking a turn for. They'll know the context of the battle. So they have access to all the information when they're making a decision. In our case, it's like it's not doing too much, but it does have now the ability, this computer AI has the ability to figure out a reasonable target. And the first thing I think we need to do is we've got to figure out like what is what, like I know what character it is, but we don't know we don't like we got to figure out, given what character it is, we got to figure out what our legitimate targets are. So, like we do have access to the heroes and we have access to the monsters. Sorry, that's the monsters player, and you've got access to the heroes and the monsters. Heroes and monsters. We do have access to them all, and we could just like look through them and find the right one. What I'm gonna do here is I'm gonna like let's break this down a little bit. Let's make a method here that says find. We'll do it this way: a list of character that is well. I want to call a method. I want to make a new method that says find targets, and we're going to pass in the character and the battle. And so we're going to just have a single method here that is, just throw that in for a second. We will revisit that line in a moment. I just wanted to compile. I wanted to generate this method. All right. So what we're going to do is we're going to say battle.monsters.contains, let's see, battle.monsters.characters.contains character. So this is a query. It does the monsters characters contain this character? If it does, so basically if this character is a monster, then return battle.heroes.characters. Else return battle.monsters.characters. Okay, that was pretty straightforward. This says it can be static, and it can, and I don't see a reason why we wouldn't want to do that. So let's make that static. All right, so now we get all of the targets, and in this case, we're just going to grab the very first one. So let's revisit this. Like, what else could we do here? We could pick something at random, which is not a bad idea. We could do, I could just throw that right in here. I think I could do random equals new random, new random, and then just do something like potential targets. Hey, actually that was, yeah, that one. That's perfect. It just suggested that. So this says pick a random number between 0 and up to 0, including the 0, up to, but not including the count. So if I have 3 things, then this will pick a random number between 0 and 2. So the 3 total options, 0, 1, and 2, which happens to be exactly what we need to like index into that. So like in this case, like, and sometimes we're doing random. It's like we gotta, in order, like if you want to roll a die and you want the numbers 1 through 6, then you say random.next 6, and then you got to add 1 to it because random.next gives you 0 through 5. So you'd have to want to add 1 to get the 1 through 6 instead. In this case, we don't have to worry about that because this is exactly what we need because our indexing here is 0 based. So this allows us to pick a random one. One catch is that there is no what happens if there are no characters. In that case, like if all the characters got finished off, then maybe what we should do is we should say something like if potential targets dot count is 0, then let's fall back to our do what do we call it, rest action. So we'll bail early. If there's no targets to attack, then basically we've already won. We'll just, what else are we gonna do? We might as well rest. It may not matter because we may, once characters are gone, we may end the battle early. We may not keep iterating through the list of characters because the decision has been made. But sorry, I'm sitting there trying to figure out why that thing was underlined. I'm wondering if I got a. I didn't even get a compiler warning for that. But this is saying this method, take turn, creates a new instance of rest action which is never used. Pass the instance as an argument to another method, assign the instance to a variable, or remove the object creation if it's unnecessary. The one thing this didn't call out, which is what I am doing, is or return it. So that's what I want to do, is just return it. So if we look for targets and there aren't any, there aren't any targets, then we do nothing. Otherwise, pick one at random and attack that. This should work if I've got 1 or 17. Now let's talk about like game design for a minute here. Is this the best AI? I kind of feel like, from my experience playing these types of games, is you're usually better off like concentrating fire. You're better off because like all of your targets, all of your enemies, they don't typically get weaker as their health drops. Like they are operating at full capacity until they are completely eliminated. Now that if that isn't true, then what I'm about to say would be different as well. But if you assume for a moment that, because generally speaking, I think that's the way this is going to be in this game, it actually makes sense to concentrate fire. It makes sense to try your hardest to eliminate enemies rather than picking randomly, because if we pick randomly, we're going to like distribute the damage across all potential targets. And I think that's workable. I kind of like that it's like not always the same thing. It's not predictable. And so so you don't just plan on, well, these guys are going to deal 7 damage next turn, so I'm just gonna you know add my buffs or whatever to like make sure I can protect that one guy from 7 damage. But distributing it randomly is perhaps not the most strategic thing. So I think I'm gonna, now that it's in here, I think I'm gonna leave it that way. But I do actually think it makes for a somewhat more formidable AI if we don't pick it randomly. If we do just grab the first one in there, or maybe a better strategy would be to like uh, either, if all damage is equal and all targets are equal, you look for the one that is closest to being dead and just focus on that. So if you've got, 2 characters, one of them that has 7 out of 10 HP and one that's like 3 out of 10, let's try and finish off the 3 out of 10 first. And maybe if that guy drinks a potion, now he's 10 out of 10, and now you maybe change your attention to the 7 out of 10 guy instead, or something like that. That could be a strategy as well. There's so many pathways you could go down on this, and we're not going to go down them all. Like I said, I'm pretty sure that the version that I had that's just the code on the website is just a very simple, just use the first one. Like I think it's just that with no random. And I think that's a pretty viable strategy, other than it's possible that that guy at the front of the line might, like, he might be able to, like, if he can, oh shoot, there's a name for that. Uh, I'm gonna sound stupid if I get this wrong, but I think I want to say it's a tank. Somebody who could just take a ton of damage. Like get that guy in that spot and just let him absorb all the damage. Um, hopefully that's the right term. I feel like I used to know that better than I do right this second. So anyway, but yeah, you just put a guy there at the front that can absorb a ton of damage. Um, would be a good strategy to counter that. And anyway, so there's a lot of nuance here. Random is not a bad option at all. And like this, but this is the kind of thing you could go nuts. You could go nuts building different AIs. And that's one of the things I like about the fact that we've got this interface is when this is all done, we like I maybe I'll take this and I'll put it on GitHub or something like that so people can do stuff with it. But it would actually be kind of fun to have a little competition at some point where 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 people go and build an AI for this and so like you spend a day or 2 hours or 4 hours or something, like we put a time limit on it and just say your goal is to build a new player implementation, and then we'll gather them all together and we will run them all against each other and we'll see who wins the battle. That might be fun. I'm probably dreaming there. I don't know that that's ever going to happen, but it would be an interesting path to go down. But that's the thing I like about how we've got this iPlayer interface in here is we could build different AIs for different things, um, to make different decisions based on, you know, different criteria. We could have one that just does it randomly, and one that always goes after the weakest opponent, and one that always goes after the uh, I don't know, the one that has the the best attack or something like that, and focus on that. So and then you could compare them really easily. You could because it's essentially super swappable. You could just use anything anytime. So okay, I think that's enough on that. And I think we are. I'm trying to let me go back and look here really quick. The whole purpose of this was to yeah to just allow them to start running their own attacks, and we did a little bit of like discussion there about the best way to do some attacks. I'm not. Oh, there was one other thing I wanted to talk about here. So let's just run this. I just want to make sure this is actually working like we'd expect really quick since we've been making a lot of changes. Oh, nope. We haven't ran this. So we're going to pass in. Oh, okay. Now we got to get rid of static. We were talking about that when we put that in there. So in order for the player to take a turn, we've got to give it the battle. Well, we are in the battle. Like this is the battle class. So when we are going to tell a player, "Hey, go take a turn, make a choice for this character," and here's the scene, here's the environment, the context. We're going to just pass ourselves in. So that's how the player is able to find out about the battle is by this guy who already knows about the player just saying, "Okay, your job is to do this, and any questions you've got for me, I can answer them about what the state of the battle is right now." All right, so that should be enough. Let's run this. Okay, yeah, this looks like it's doing what it's supposed to. So skeleton used operating. Skeleton used bone crunch on RB. RB used punch on skeleton. Anyway, so it looks like it's doing everything it's supposed to do, and I think we are good to go. I have had people ask a question here on where did that go? Like why like what's up with this versus some of the other things you could do? This flavor like this is a property, and like because we're using this expression body, the fat arrow, the lambda operator. Um this is the equivalent. I'm going to write this out. This is the equivalent of return new. What's this? This is punch. It's exactly equivalent to this. It only has a getter, and then it just returns this. Now the downside to this is this punch attack. Like we are every time somebody says, well, "Hey, what's your standard attack?" Every time we do that, we create a new punch instance. And making new instances, these are like, this punch instance is really not that big. This actually, honestly, this really doesn't store much. This string is stored elsewhere, and it's a compile time constant. This string is actually going to be put in a special spot, and it, like, even if we had 50 you make 50 instances of this, we weren't going to have 50 copies of this punch string. Same with bone crunch down here. So we don't have to worry about these taking up too much memory. The garbage collector is going to have to do a little bit of work to clean up. Oh, great. What did I just do? I just broke something. How I did that, but in theory, it might be better to do something like, we don't want to create all these objects. Like, we could even do something like, we'll just make one. We'll make one instance, and then we'll just say return the punch attack. So now there's only one instance ever created. We just share it around. And given that this thing doesn't have like its own data, like, it's totally fine for this there to only be that one instance that we create. Like, it's okay for us to share that instance because there's no like specific, like, the only data that this attack has is, it's just the name, and it's okay for us to share that. So this version creates fewer objects because there's only this one. And it doesn't even matter how many skeletons we have. There will only be one punch attack shared across them all. And again, given that the only thing we do, like, conceptually, it feels just a little bit weird to me that all the skeletons share a punch attack, because it kind of feels like the attack is something that the skeleton should own. But really, given the nature, like, there's no reason to like make lots of extra instances of it. They're all functionally equivalent. So we can do this, and I think this would work. The one thing I would say though is, especially, well, yeah, let me do it this way. If I delete that, so now there's, the way this is set up now, there will be one per skeleton. Every skeleton that gets created will get its own punch attack. But if you ask for a standard attack 70 times, you only create the one. So this is kind of somewhere in the middle. But what I will say is we could, like, the alternative here would be to just do this, which is subtly different from this one's bone crunch. Odd. Yeah. So the difference between, like, you can compare this versus this. This is the code that will run every time you call it. So this will make a new punch every single time. This version, the compiler will generate, because this is an auto property, the compiler will generate a backing field for it, and then it will initialize that backing field with this. So in this case, we'll make one for every skeleton that's in the game. There will be one bone crunch attack, and calling the getter is only gonna, like, it'll only go retrieve that instance. So this creates fewer instances at the cost of a few more characters. And sometimes there's scenario, like, if this is supposed to create data, and then maybe that data for the attack changes over time. I'm trying to think what that would be, but there are some possibilities as you're making this game that you could have an attack that, like, well, and I mentioned something in one of the other challenges in one of the previous videos of, like, you could have something that, like, changes it to night or changes it to rainy. And so then you can have like some sort of weather effect that will take all punch attacks and like reduce them in half. Or like double the damage for bone crunch attacks if the environment is a graveyard, or I don't know, something like that. Like, you could do that, and then maybe the data would change over time, in which case you may want to have a new instance every time, like this guy does down here. At any rate, 1,000 little teeny decisions, and they are all lots of trade-offs, and that's literally the nature of software development, is figuring out among all your possibilities which ones give you the right balance in terms of trade-offs. And and I think that's what makes that I think that's what makes it so tricky sometimes, is that there's very often several ways to do something, and it isn't always obvious what you should like be optimizing for. What things should you be prioritizing? Like in this case, should we be worried about the number of objects that are being created, or should we be willing to create a new one so that its data can evolve over time? Or like how should we do that? So, um, you and your experiences and the specific game you're trying to make or the specific program you're trying to make will drive a lot of that. And the right answer for your even with this exact same final battle challenge, the things that you end up wanting to do with it may be different from the things that I did, especially if you look at some of the expansions. You got some flexibility, and the thing you're building may legitimately need a different design than what I've got. And then of course there's a bunch of just subjective things like how much does this matter? Well, I don't know. I've you know if for example you're the kind of person who's been bit by way too many objects being created and the garbage collector having to work hard, this kind of thing may you may sit here saying this feels wrong to be creating new instances unnecessarily because you've been bit by that in the past, versus somebody else who maybe was bit by thinking that it was uh, that you were getting new objects, and no, you were getting the same object over and over again, and and so you started making changes to it, but you didn't realize that was changing like everybody's version of it because you thought you were getting a unique one. So I have been bit by both of those. And so ask me on a different day and I will have a different answer. But let's say for now, let's leave this alone as it is. So we'll just create a new instance every time. I think that'll be okay. It really isn't going to be that many new instances. Um, let's see. Let's make sure. I think we've got everything done. The game runs like it's supposed to. The hint has some discussion about like having a get party for character. In this particular case, like we solved that. Honestly, I like this version better than what I did on the website and what's mentioned there. I like. Now I gotta find it. Maybe this single file is getting too big. I like we just solved that really easily here by just this right here solves the problem of that get party for character and get enemy party for. This just says find me the targets, and if it's a monster, return the hero characters. If otherwise, return the monster characters. So personally, I like how we ended up doing this better this time than what I had on the website. But that's it, and I think we're done with this challenge. So thanks for joining me on this one, and I will see you for the next one.